Hello, my beautiful computer science students. Welcome to another lesson where I, Goldie, take you through our AP CSA lesson, Unit 3, Lesson 3. We are still working with Boolean expressions and if statements, and this time we're actually going to get to the Boolean expressions part and talk about what that means. So we'll be introducing Booleans as well as truth tables in this lesson that are going to help us evaluate these Boolean statements. So let's get into why we have Boolean operators. So when we check two conditions, like let's say we want to check whether a number x is between 20 and 30, okay? Java can only answer one comparison operator at a time. It can't compute compound comparison expressions. And you've seen compound comparison expressions in your algebra classes. So something like this would be incorrect. Java will protest at this, okay? This is not the correct syntax. Even though we're used to seeing it in algebra, the computer can't answer this question because you're essentially asking two questions in one. Is x greater than 20 and is x less than 30? So there's two questions there. Now, we can solve this without a Boolean operator. And the way we would ask two questions that we know of right now might be something like this, using nested conditionals. If x is greater than 20, then we enter the if statement. If x is less than 30, then we print off that the number is between 20 and 30. Okay? So this would be a perfectly fine way of checking two conditions. Now the problem with this is if you have multiple of these in your code just gets very long. And it's really up to you as the programmer, I suppose, but there is a much more elegant solution, and it comes in the form of Boolean operators. Boolean operators allow us to overcome that disadvantage of only being able to ask one comparison operator at a time. So Boolean operators allow us to compare multiple Boolean expressions or multiple comparison operators. The Boolean expression evaluates to true or false, and then a Boolean operator will determine, based on the results of that, will it evaluate to true or false. Okay, Boolean operator compares the true and false values that you get, and there are three of them that we are going to be talking about in this course. There is technically a fourth one that I'll talk about a little bit just to kind of show you, but it's not required in AP CSA. The only three that are required in AP CSA are what we're going to go over right now. The first one is the AND Boolean operator. The symbol is the double ampersand. Okay, so two ampersands right next to each other. And what it means is that it evaluates to true if both conditions on either side of that symbol are true. Okay, so here's our first introduction to a truth table. Okay, if you've seen them before, you love them. If you haven't seen them before, this is a basic example of a truth table setup. You have two columns of just regular variables, A and B, and you go through all of the different combinations of what A and B can be. And remember, A and B are Booleans, so they can only evaluate to true or false. And you look at all the different combinations of true false you might get with A and B. And then in that third column, you have your Boolean operator. Okay? So here's what it looks like. So first off, for A, we set up two truths and two falses. And then in the B table, we set up true, false, true, false. And the reason we do this is to look at all combinations of what A and B can be, right? So A and B can both be true. A could be true, B could be false. A could be false, B could be true, or they could both be false there. Okay? So that is a truth table setup. That's how we set up all truth tables, is the combinations of A and B. And then in this third column here, we evaluate the Boolean operator, A and B. So the ampersand, the double ampersand, it evaluates to true only if both conditions are true. So when A and B are both true, it evaluates to true. So that expression A and B evaluates to true because both conditions are true. However, if one or both of the conditions are false, A and B will evaluate to false. Okay. So that's the logical Boolean operator, the AND. It evaluates to true only if both conditions are true, otherwise it's going to evaluate to false. And we can use this one to rewrite that example we just went over. If we want to write an if statement to determine if a number is between 20 and 30, the key there, and you'll look for this language when you're writing your programs, you're looking for an and, right? You're looking for both conditions to be true. If x is less than 30 and x is greater than 20, then x is between 20 and 30. Okay, so that logic, that and, is right there in our problem statement, and then we use that and in our code. So here's what that would look like with that Boolean condition. If x is greater than 20 and x is less than 30. Okay, so it allows us to compare this and this. And we'll talk about order precedence in a couple slides here, but what Java does, it evaluates this, and it evaluates this, and it does the Boolean operator last. Okay? So it's going to get the answer to is x greater than 20, it's going to get the answer to is x greater than or less than 30, and then it's going to compare them. And if those are both true, then x is between 20 and 30. Okay. So that's the first one, that's and. The next one is the or logic operator, and it has the double vertical bar. So your vertical bar on my keyboard, it's the upper symbol underneath the backspace. Okay, if you want to locate it, if you have another weird keyboard, I guess it might be somewhere different, but it's right above the backslash. And that logic symbol evaluates to true if one or both statements are true. So let's set up our truth table again. Again, A and B are just all possible values of, or all possible combinations of true and false. Okay, so then the or, it evaluates to true if one or both statements are true. So if both statements are true, it's going to evaluate to true. Okay, if one statement is true, it'll also evaluate to true. Okay, but the second both are false, it's going to evaluate to false. So that's your or. Okay. And I have another example using an if statement. So write an if statement to determine if x is greater than 18 or less than or equal to 21. So again, right in that problem statement, you see the or. Okay. So that clues you into, okay, I have to use the symbol or for that. Okay. So x greater than 18 or x less than or equal to 21. And I write it just like that. Okay, so I'm translating those words, that problem statement, into my code. X greater than 18 or x less than or equal to 21. Perfect. And then the last one is the logical not symbol, which we've kind of seen before with our not equals to. Just the logical not symbol is the exclamation mark. Okay. You've seen it go with your not equal to in a comparison operator, but just by itself it's called the not symbol. And what it does, it switches the Boolean values. Okay. So let's say for our A, we have true, true, false, false. Not A, if I look in that third column, not A just switches that value. So it becomes false, false, true, true. Okay. So it's just it's a switching operator. So same thing with B, true, false, true, false. Not B, in that last column there, is just going to switch everything. False, true, false, true. Okay. So we use the not operator in front of Booleans, and it switches the logic like we did in that truth table there. We can also use them in front of comparison operators. Okay, so that's that last example in that box there. What does the following if statement ask? Okay, so you see the if, and then you have the not, and then you have this comparison. Then you have the or, the not, and then you have this comparison. So you have a couple things going on here. Okay. In words, what we would translate that to, if the age is not greater than 18, or if the age is not less than or equal to 21. Okay. So again, that either or, because we have the or operator, but the not switches that comparison operator meaning. Okay, so age greater than 18, Not age greater than 18 is just not greater than 18. Okay, so the not operator switches those values. Okay, so here's a fun piece. Okay, truth tables are very helpful to determine if two expressions are equivalent or to work out more complicated Boolean expressions. Okay, so here's what I kind of have going on here. I almost have two examples in one here. Okay, two examples in one. Okay, so I'm going to kind of draw a line there. Just that line will disappear here in a moment, but just to show you, this would be like, let's say I wanted to evaluate this expression. Okay, and I said, what does that expression evaluate to? Okay, not x and y. What we would do with a truth table to help us figure that out is first evaluate what not x is, and that's why I have a column with the not x. And then I can compare this not x column and my y column to see what that evaluates to. Okay, so let me do this example first, and then I'll talk about all of the columns to the right. Let me just work on this example. So not x switches those Boolean values, right? So that's what you see in that row. Not x is false, false, true, true. Okay, and then when I want to evaluate this expression right here, I compare the not x column and the y column, okay? And I look between the two, right? And determine what and would evaluate to. So not x and y in that first column is false and true. And what does false and true evaluate to? It's going to evaluate to false, okay? Because one of them is false. This next row, false and false, evaluates to false. The next row, true and true, is going to evaluate to true. Okay, and then the last one, true and false, evaluates to false. Okay, so this right here, what I put right here that I'm circling, this is just kind of the work for it. You don't always have to put that down in your truth table. You can just write false, false, true, false, especially once you start kind of getting good at truth tables. But I just wanted to kind of have a visual of what exactly was being evaluated there. Okay, so that's that example. Okay. Now let's move on to the second half of this table, which looks crazy, but I promise it'll be okay. Okay, so the second half of this table actually has us evaluating this crazy expression, right? If I were to give you this crazy expression and I said, what's the result of this truth table? And you're looking at that and you're going, holy cow, how do I even start that? Okay, you want to break it up into smaller problems. So you'll see first that I have a not y over here compared with this over here, right, with that or. This gets evaluated last in order precedence. Okay, so the not y, I can come up with a row for this, and then I have to come up with a row for that first half. Okay, and that's what you see right here, x and not, and then in parentheses that whole other thing, right? So in order to figure out this row, okay, I need an x column, which I already have way over here, and I need this column. Okay, I need to figure out what that column is. So that's why I have this right here. Okay. Now I have a not symbol right in front here, and then in parentheses, I have this expression. So I need to figure out what that expression is, x or not y. And again, I already have my x column. I do need a not y column. Okay. And that's why I have all of those columns. In order to figure out that complicated Boolean expression, you can use your truth table as a set of stepping stones to get there. Okay. Yeah, it's very fun. Now, would you have known that right off the bat right now? Probably not. Okay. You wouldn't be able to kind of figure that out. We haven't talked about order precedence yet, and we haven't really had enough examples to really understand how to set up our truth table. But we will. Okay. I'm showing you an example of how we use it, and then the more practice we get, eventually you'll be able to set up your truth tables like this. Okay. So let's get started with our not y column. Okay, so not Y switches true to false, false to true, true to false, false to true. Okay, so that's my not Y column. This next column is going to compare X or not Y. So here's not Y and here's X, and I'm going to compare them using my OR operator. Okay, so X or not Y. So that's going to be true or false, which evaluates to true. Next row, true or true, also evaluates to true. False or false will evaluate to false. False or true evaluates to true. Oh, and I guess I got the next row popping up already. Okay, this next row just switches because it has the not symbol in front of that row I just did. So I'm just going to take these values that I just did, and I'm just going to switch. Okay, because I had that not operator there. Okay. So I got that row. The next one is the and X and that row I just figured out. So this row with my X. Okay. That row with my X. So I'm going to be comparing those two rows, or I say rows, sorry, those two columns with my ampersand, with my and logic. Okay. Oh my goodness. Okay, so there we go. So true and false. So X is true, and then this row is false. True and false evaluates to false. Okay. Then I have true and false. Again, I'm getting that from this row and this row. True and false also evaluates to false. I got false and true. It's going to evaluate to false. And my last one, false and false, also evaluates to false. So this is a good example of an expression here that will always evaluate to false. Okay? No matter what combinations of X and Y's you get, that expression in that column will always evaluate to false. Okay? Which has been previous AP exam questions before. Okay? What does this expression evaluate to? On the multiple choice section, it'll say always true, always false, only true when X is true, etc., etc. So this is an example. This expression always evaluates to false, and we used a truth table to determine that. But we're not done yet. So we just evaluated this column right here. Okay, so that's what this is. We're going to compare that column with our not Y column, okay, which is over here. Okay, so I'm going to be comparing these values with my OR. Okay, these values with my OR. So I got false or false, which is false. True or false, false or true, excuse me. False or true, which is true. False or false, which is also false. False or true, which is going to be true. Okay, so this is an example. If you look at false, true, false, true, where else do you see that pattern in the truth table? You see it, where is it? Right here. Okay. You see that same pattern over here. So that means that this expression matches the not Y logical expression. So just some things to notice. If you're working this out with a multiple choice question, they usually ask questions, this is equivalent to what? It's equivalent to a not Y. Yeah. Okay. Very fun. Truth tables are so exciting for me because it's logic. Okay. And when I say it's just logic, it makes it sound like it should be simple. But as you see, it can be like a big puzzle, okay, and it can take some time to figure out. So we'll keep practicing these, and eventually you'll work your way up to being able to figure these out. Or maybe you already can. Who knows? Maybe you're better than me at them. Let's talk about this precedence that I alluded to earlier. Okay, it's because we're getting a lot of symbols in here. How does Java know which one to evaluate first? We have an order precedence, and I had to split the table up into two pieces here, but in the table, first is your grouping symbols. Your grouping symbols always take order precedence. Always evaluate what's in parentheses first. Okay. Next is unary operators. So this would be if you have a negative symbol or you negate something. Okay. With that logical operator. All right. Which is why usually if you negate something, you see the negate symbol in front of something with parentheses because it wants you to evaluate that in parentheses and then negate it. Okay. But your negate symbol technically comes up there. Then it's your arithmetic operators. So this is what you're used to, right, in terms of order precedence. Remember that these have the same precedence in terms of order. Okay, so it's just in order from left to right, whatever you see first. Same thing with your add subtract. Then comes your comparison operators. So you do all your arithmetic operators first, then you do your comparison operators. Okay, so these actually are first in order precedence, followed by the equals and the not equals. And then your Boolean operators happen last. Okay, we didn't talk about this one. This is not on the AP exam. It's called the exclusive OR, and that's actually what your caret symbol is. Okay, so we talked about how your caret symbol is not an exponent. It actually represents your exclusive OR. I'll talk about that in a moment. But here are your other two operators that we did talk about. And notice how the AND comes before the OR. Okay, your AND will always get evaluated first before the OR. Okay, they don't evaluate in order from left to right. It's always the ANDs, unless of course you got parentheses, right? So if you had A or B and C, let's say for instance, this gets evaluated first. Okay, so that's very important, unless there's parentheses. Okay, so if there's like this, then of course you would evaluate the OR first because it has parentheses there. Okay, so be careful of that. This exclusive OR, I always have students ask what it means, even though it's not on the exam. Let's talk about it real quick. Let's just do a quick truth table to show you what it means. True, true, false, false. There are reasons you might want to use an exclusive OR in a program. We just don't encounter them in the programs we write right now. But exclusive OR means that it will evaluate to true only if one of them is true. Okay? So if both are true, it evaluates to false. If one of them is true, it evaluates to true. And if both are false, it evaluates to false. Okay? That's your exclusive OR. So it's either or, excluding the both is kind of how I think about it. Either or, but excluding both. Exclusive OR. Not on the AP exam, we focus on the and or. Okay, so I've shown you how we use truth tables to evaluate Boolean expressions. Let's look at some examples of what we can do when we already have values for our Booleans. What I mean, let's say we have the following declaration. We know X is true, Y is false, and Z is false. Okay, so we have that declaration. What do the following statements evaluate to? So in this case, we have values for X, Y, and Z. So we don't have to make a truth table. Excuse me, you could. It's just more work than you need to. What I like doing to evaluate these is actually plugging in what those values are, right? So for this first one, plugging in T for X because it's true, F for Y because it's false, and F for Z because it's false. And then going through and evaluating these. So this first one, I would do, parentheses first, false and false evaluates to false, right? And then you're left with true or false, which evaluates to true. Okay. So when you have those set values, you don't need a truth table. If you didn't have set values, that's when a truth table would be useful here. Okay. Okay. Same thing here. I plug in values, true for X, false for Y, and then I evaluate it. So I do my parentheses first. True and false will evaluate to false. Then I do my not operator, which is it's called a unary operator, but it's your logical not, which switches both of those to true. True and true is going to evaluate to true. Okay. And I wanted to make sure, yeah, there's no typo here. It is what it is. Okay, and let's go through and I'll show you how to evaluate this. Okay. Plug in the values. Plug in your values. Am I sure there's not a... Yep, sorry. This will be gone by the time you get your notes. I don't think I meant to put a parenthesis there. Yep, because then I got not true, false, false, false. Yeah, that's what I meant to do. So no parenthesis there. Okay, perfect. So I plugged those values in. Sorry for that typo. Now, what do I do first? Because I have two sets of parentheses. I do the inside set of parentheses first. So false or false evaluates to false. Okay. What I also did in that same breath, I did a not t, which is false. Okay. So I did this and I did parentheses first, and then I also did the not t because that would be what my next step was. I just did two steps in one. Okay, now between these ones, it actually doesn't make a difference here because it comes out to be the same either way. But remember between the or and the and, because I got my parentheses here, I have two Boolean operators in there. The and does take the precedence. Okay, when you have two operations inside parentheses, you got to look at the precedence first. The and takes precedence. So false and false would evaluate to false. You get the same answer either way, but sometimes you won't, so please be careful of that. False or false evaluates to false, and then not false is true. Okay. So all of these ended up being true. Okay. Now let's look at negating comparison operators. So let's involve some comparison operators now that we've kind of gone through the examples with Booleans. So negating a comparison involves switching the comparison operator basically to the exact opposite operator. So I always think of a number line when I try to picture this. If I wanted to graph x is greater than 4, think back to your algebra classes. How would you graph that on a number line? You would do an open circle on 4 and then shade everything greater than 4, right? Now, what if I asked you to graph not x greater than 4? Okay. The negating of that's called a negating comparison operator. So you are switching that comparison operator to the exact opposite. And the exact opposite of that is shading in the 4 and shading everything less than 4. Okay. And what is that? That's x less than or equal to 4. Okay. So a comparison operator, when you negate it, it has the exact opposite operator. Okay. And when you are negating it, that's what you are switching it to. Okay. So here's all of our comparison operators, and let's talk about what they are equivalent to when we negate it. So this example here, not x less than or equal to 4, when I draw that out and write the equivalent to that, that's going to be x greater than 4. The exact opposite operator. So if it's an equal to, then it's not an equal to. If it's less than, then I switch it to a greater than. Okay. So this one over here, greater than or equal to, is equivalent to less than. Less than is equivalent to greater than or equal to. Greater than is equivalent to less than or equal to. Okay. And then your equal to, not equal to, that's a little bit easier. Equal to is equivalent to not equal to. Not equal to, when I negate it, is equivalent to equal to. Okay. So those are all of the different combinations of comparison operators and then how we negate them. And I just have a couple more examples in this lesson, and then we're going to wrap it up. Okay. So let's say if I wanted you to evaluate the following expression. So what do they evaluate to? True or false? Okay. So we have, in here, we have comparison operators and Boolean operators. Now, luckily, everything's kind of grouped together with those parentheses. If there were no parentheses here, okay, along either of them, it wouldn't matter. The comparisons get evaluated first. The parentheses are there because it's a nice visual. Especially as a computer programmer, you want to try to help your eyes where you can. So adding those parentheses really helps. You visualize this, but comparison operators always get evaluated before Boolean operators, whether there's parentheses or not. So I'm going to evaluate this. First, is 2 less than 3? That's true, right? Next comparison, is 4 not equal to 5? That's true. And this last one, is 6 greater than or equal to 13? That's false. Okay. So the comparisons, remember, ask a question. All right. And then that question evaluates to true or false. That Boolean expression evaluates to true or false. And now I'm left with my Boolean operators. Okay. The and gets evaluated first. True and true is true. And then true or false is also true. Now this second one, I see the negating happening, and you can do it one of two ways, because we just talked about how we negate comparisons. You can take this and actually negate it and switch it to its logical equivalent. Same thing here, 5 less than 10, and then this one doesn't have a negate. And then you can answer the question. Is 3 greater than or equal to 4? That's false. Is 5 less than 10? That's true. Okay. So you can do it that way, or you can just answer this question right in here. Is 3 less than 4? That is true. And then we negate the true and make it false. Okay. Same thing here. We can take 5 greater than or equal to 10. That's false. And then we negate the false, and that becomes true. Okay. So you can do it either way. However your mind kind of thinks about these problems, whatever you like to think about. Me personally, I like answering the question in parentheses and then negating it after. So that's why you see here not true or not false and false. Okay. From here, the nots happen first before your Booleans. Before the ors and the ands. So that's why I switched it to false or true and false. The and takes order precedence. So false or false, which evaluates to false. Okay. Here we go. All right, let's get to our last example. Following declarations, I have 3 numbers. What do the statements evaluate to? Again, think of it like a giant puzzle. We're figuring this out here. When you have set numbers or set values like this, I just recommend plugging them in, okay? You don't have to come up with a truth table or any sort of tracing table when you have set values. So I'm going to plug in those numbers for num1, num3, and num2. Now what I have is a big mess of exciting things, okay? I have comparison, Boolean, operator, comparison. Okay. So you got to remember your precedence. Now, the AP exam doesn't go crazy with precedence, okay? But it's just good to remember what to do in these situations. Remember that your your arithmetic operations happen first. So that 24 mod 8, that's the first thing that's going to happen in this lineup here. Okay. Arithmetic operators happen first. So 24 mod 8, when you take 8 and divide it into 24, 8 goes in evenly to 24. There's no remainder. So that evaluates to 0. Okay. No more arithmetic operators, so next is the comparisons. So this is going to happen, okay, and this is going to happen. Okay. The and gets evaluated last. Is 3 less than 24? That's true. Is 0 equal to 1? That's false. Okay. So you'll be left with true and false. True and false. Ooh, excuse me. Evaluates to false. Who wrote this? True and false evaluates to false. Okay. Okay, last example, and then we're done. Last example. Same situation. Let's plug in those numbers. Okay. 3 times 8 less than or equal to 24. All of that is in parentheses. And then same thing on the other side here. All of that is in parentheses. That's nice. Remember that inside those parentheses, when you have your arithmetic and your comparisons, the arithmetic operators happen first. So 3 times 8 is 24. 24 minus 12 is 12. Okay. Then in parentheses, you get the comparisons. Okay. So those will evaluate the first one, 24 less than or equal to 24, that's true. 12 greater than or equal to 10, that's also true. But then I have my not, which switches that to false. False or true, that's going to be true. Okay. Remember that this is false over here. That's bothering me. False over there. Good. That's our last example for today. That was Booleans and truth tables, where we evaluated those compound Boolean expressions, and then we compared and contrast those other Boolean expressions. Okay. Very fun stuff. So that wraps up our computer science lesson for today. Thank you guys so much for following along, and I will see you next time.